Hello. Today I would like to demonstrate one way that CAD can help you solve engineering problems. Here's a fairly advanced undergraduate statics problem. Actuator link DE is used to drive the link OP through links BC and AB. The length of each link is given and the location of the grounded pin joints O, C, and E are known. For a given mass of link OP, the task is to find the force in the actuator as a function of theta. To analyze and discuss this problem, we need to assign a few variables in a couple coordinate systems. Theta 1, 2, 3, and 4 are defined as the angles between each link and the horizontal. The XY coordinate system is centered at point O, and the X prime, Y prime coordinate system is centered at point C. Summing the moments on link OP about point O will reveal that if we know theta 1 and theta 2, then we can compute the force in link AB. If we can determine how theta 2 depends on theta 1, we should be able to build a function that will give the force in link AB as a function of theta 1. Likewise, summing the moments on link CB about point C will reveal that the force in the actuator link ED is a function of the force transmitted by link AB, theta 2, theta 3, and theta 4. In short, if we can determine how each of these angles depend on theta 1, then we can find how the actuator force depends on theta 1 and produce the desired plot. One approach is to use trigonometry, algebra, and geometry to develop functions that may be solved or plotted. For this approach, you'll likely spend a lot of time sketching, using trig identities, and correcting mistakes. Another approach is to use CAD. Here is a CAD model in SolidWorks. I've included an image from the problem statement as a sketch feature for reference. I've changed its transparency to 0.9 to make it faintly visible and allow the sketch lines to be apparent. Let's close the sketch picture and take a look at the geometry in the sketch. Inspecting the dimensions on this sketch, some of the dimensions are dark black, like this 480 millimeter length. Others are light gray, like this 23.50 degree angle. The light gray dimensions are driven, meaning they're just reflecting or indicating what a value is given the geometry. The dark values are driving dimensions, so they're actually driving the parameters that constrain the geometry. Let's make it a bit bigger to make that change more apparent. So you see that dimension is actually driving the geometry of the object. Let's change it back to 480. If, on the other hand, we click on this light gray model, we'll get this error that says this dimension is driven. It's just indicating the value that currently exists in the model. So I'll escape out of that, and I can move this link, and the angle will update and reflect that change. Using Control-Z to change that back, we can continue our investigation. Now let's find the limit of theta 1 by making these intermediate links collinear. Selecting the first link and then using Control to select the second link, we can add a collinear relationship. That gave us an error. Sometimes that happens. It doesn't always mean that there's no solution to that parameter. I'll Control-Z to undo and move the model to where it's a little closer to the actual solution that we're looking for. So we're trying to get this gate as high as it can open. So now let's try to Control select our two intermediate links and make those collinear. This time it happens and we can see that the limit on our angle should be 66.99 degrees. I'll escape and use Control Z to undo that change. Now let's turn theta 1 into a driving dimension. So I right-clicked on the dimension and unclicked driven, so now you see it's dark black, and if I change that angle to, let's say, 10 degrees, then the model will update, and you see I can simply read and record theta 1, theta 2, theta 3, and theta 4. I'll change that angle once again to 5 degrees, and you see we get another set of angles. Those could be recorded. If you'd like to get more decimal points, there's an easy way to do that. Go to Options, Document Properties, Dimensions, Angle, and you could set the precision to 4, 5, 6, however many decimal places you'd like to record. I'll set it to 4. Okay, now we have a set of data that we could put in an Excel worksheet or MATLAB. So here are the input data that I've collected from CAD. These data are the X and Y coordinates of point A, the X prime, Y prime coordinates of point B, the X prime, Y prime coordinates of point D. X sub CM is the center of mass of link OP. Force in link AB can be determined by summing the moments about point O on link OP, and force ED, which is the value sought, can be determined by summing the moments about point C of link CB. You could use CAD to populate these data for angles between the minimum and maximum angles. Then, using some basic trig, compute your points. Using Newton's second law and summing the moments, compute your forces. Then you can plot the force in ED as a function of theta 1. I hope that helps get you started using CAD to solve engineering problems. Good luck and have a great day.